So on to topic 3. So this is the new section, and we're going to look at how do polymers work. So I'm just going to start with the basics for this. We'll probably pick up on some of the things we're talking about now, but we'll go into more technical detail later on. But I think it's important that we've all got the sort of base understanding before we move into something that's too technical, too deep. So if you look at the basics of applying actives to seed, what you'll usually find is that these actives are in the forms of solids or loaded onto solid carriers, and when they're applied to the seed surface, they can be quite coarse and therefore make the surface quite rough, and they may not adhere well to the seed surface itself. So the entire reason for putting a polymer around that kind of seed would be to help smooth out the roughness and also to form a continuous film that will keep that active in place around the seed. So there's two main methods for applying the polymers, the slurry method and either spinning disc or a spray gun. The simplest method is the slurry method, where the polymer has been diluted down and is added to a moving seed mass, and the polymer is spread from seed surface to seed surface with excess liquid running across that surface and going from seed to seed. The other application method is the spinning disc, and in that process the polymer itself is atomized into small droplets, and they hit the seed surface, and increasingly those hits cover more of the surface and begin to overlap, and then they start to join together, and in that way they give you that complete coating layer around the seed. So once the polymer is on the seed surface, it then has to go through a drying process. So in our case, all our polymers are water-based suspension concentrates, which basically means the solvent that we use is just water. And that needs to be driven off from that coated seed, either by heating during the drying process or through evaporation. Some of that water can be absorbed into the seed itself, although that's obviously not the desirable outcome. Therefore, drying is the best way to remove that water and maybe remove some of the excess that's been applied. And it also helps form better films. We'll cover why that happens later, but it's just worth noting that a drying step will give you an improved polymer coating. So if we look at the actives or the pigments, they behave in similar fashions. They're both small solids that become locked in the film matrix. And this happens when the polymer particles coalesce during the drying stage. So what you're seeing is that initial stage with all the liquid in, everything's going around in that concentrate all together. In stage 1, then we move on to stage 2, where the water is driven off. And what will happen is the polymer particles will start to coalesce and form that film together. And in the process of that, they'll entrap the actives or pigment particles within that film. So going back maybe another step and looking at to what actually is a polymer. In their simplest form, we look at the C-coating polymer that will just be a binder only, so that basically just a film-forming agent. And these binders are made up from polymers, which are long-chain molecules. So that's basically just a chain made up of very simple molecules put together. So you'll see here we've got an example of your sort of H2O, which is your water, or your oxygen molecules. We're looking at slightly more complicated structure than these, which will form what we call monomers. And all you do with the polymer is putting a whole chain of those monomers together, and that actually gives you your polymer. So in the case of the bottom there, what we've got is ethane becomes polythene, which we all know is a nice plastic. So that's the basics, really. So if you look at the chemical background of what polymer is. So like I said, there's different polymer types, and that was mainly the binder-only type. Within the range of C-coating polymers, there are also other additives. So we've mentioned the color already. So you get binder and color mixed together. You also get binder, color, and the effect pigments all put together as well. And that's what a lot of polymers in our range are. And more functional ingredients are being added into the polymer. And these can be all sorts of things that we'll cover off in a bit. So appearance has come up a number of times, but it's not really what we mean by a functional polymer. What we're trying to describe is a C-coating polymer that has some additional advantage. So those coatings that improve flow or plantability have an added function. And then there might be some that improve the germination characteristics or plant growth. And there's a great deal of things that we could list in this area, and it's a real growth area for seed coatings. Some of the things we might be looking at down the line, those things that do improve seed growth. So simple nutrients is often a common one that can be found in this area. So that's really just a sort of introduction to the main basics behind polymers. And now we'll have a look at the actual coating equipment. And, you know, can we use any sort of machine for this, or does it need to be a special machine? So if we look at the sort of the more conventional type of equipment, then you've got on the left a typical rotary seed coater, which consists of the rotor or the moving disc as the base and the stator or the stationary cylinder around the whole machine. This was only introduced within the last 30 years. Before that, you're more likely to see different styles of pan coaters like the one in the top right, or sort of auger feeders. And there's now combinations, and you see in the bottom left there's a combination of a rotor and a continuous mixer together. And auger feeders are quite common, like I said, and also paddle mixers have been used in the past. And even things like cement mixers and barrels that you can see here have been used for mixing the seed. And you'll get fairly reasonable results from all of these methods. Some of them will employ the slurry method, and some will prefer this sort of spray or spinning disc method. In terms of coating the surface, you'll find that the spinning disc is slightly superior to the slurry method. And also in terms of speed, rotary coaters tend to be a lot quicker than some of the older methods. And that's why the industry is moving to adopt those machines for coating. So if we look at the pan coating process, and the way the seed moves within that process, you'll see that it's more or less a rolling motion in just 2 dimensions. And the liquids or the polymers are applied to the top surface using a spray gun. Excuse me. And the speed of the pan will be determined by the seed mass and how well that moves within the pan. So a lot to do with gravity and frictions, not too much to do with the actual control of the operator. If we look at the rotary coating process, then you still have that 2D tumbling motion within the seed, but you also have, from the rotary system itself, you have a third degree of motion. And therefore, you have a complete tumbling mass of seed, of which you have more control over the speed that you can use for moving this around. So because of that better movement and that greater control, it allows more even coverage and a faster application rate. There's also an interest in batch or continuous processing. You'll find that in terms of batch processing, you'll get more accurate results for your coating, but it may give you problems when you're looking at doing volumes. So people who are looking at doing very, very large volumes will prefer a more continuous process, and they'll give up some of their accuracy to get that. But like I say, there are mixed systems as well, so there's not always one simple answer. This is just an example of one of those kind of systems. So this is the spin and slurry method kind of put together. So what happens here is the seed enters through the top, it hits a disc, and then it has a spinning atomizing disc below that, which initially coats the seed, and then as a second part of that process, it then moves through an auger process. So that's a combination of two for a continuous but more accurate type of machine. Okay, so that brings us to the end of our new topics. So if anyone has any questions, please go ahead.
So if I can throw one in there, Simon, with regards to I suppose, drying once it's come out of your coater, what are your thoughts on prior to the seed, from the seed going out of the coating machine and heading towards the dryer, in having a section of conveyor where you're just using ambient air prior to going to the drying machine?
There are dryers that have different stages for drying itself, so you'll often find that they will have either sections where they can have different temperatures.
Yep.
Have cool air at the beginning, hot air in the middle, and cool air at the end. So I think anything that keeps the seed moving and puts air across the seed, again, increasing the temperature is going to improve your polymer coating in general.
Okay.
Simon?
Next question.
Simon?
Yes.
A binder, is that in fact a polymer without color?
Yes, it is. Yeah. So
okay.
It shouldn't really, those two terms shouldn't really be used the way they are, but unfortunately that's the way it's kind of happened in the industry. Yeah, we have to be careful when we're talking about binder or polymer as to what people actually mean. Sometimes they mean just the binding component on its own, sometimes they mean all the ingredients together.
Okay, so in fact, what we call a binder or one of your, let's say, products, glaze or flare, whatever, is a binder plus color.
That's right. So things like flare and blaze, I would normally call polymers. If I was going to talk about binders, I would probably be talking in the sticks range.
Okay. Okay, so a customer can, in fact, get a binder or a sticks, get a color from wherever he gets it, and has his polymer, what we call it.
Yeah, there's a whole range of options out there.
Okay, just to be clear, what the terminations are.
Yeah, I mean, some people will use one of the binder products like the sticks. They will also bring in the sort of the pigment color product, but separately, and they may even put a finishing powder in there as well. So they will end up with something that looks like it was coated with a flare or a blaze product, but they've made their own sort of ingredients put together.
And so, maybe it's not the subject, but when you do pelleting, you also use some kind of binder. It's the same?
It can be the same, yes. Yeah.
Okay.
Yeah. Hi, Simon. This is Raghavendra.
Hello?
Yeah. What is the best method of application in 2 layers?
In 2 layers.
Yeah.
If you really want discrete layers, you're better off using a pellet. If you can't do a very large build-up, probably it's better to do a film coat, have a drying stage, and then do another film coat.
Okay, means in the first layer we have to do a first coating, and then we have to dry properly, and then we have to go for the second layer.
If they need to be separate, then that's the best way to do it. If it's not so important, you can apply one thing later than the other, but you will get some mixing between those layers.
Okay, thank you. But we did the film coating in the first layer. After that, we have dried it, and then we have applied second layer. But there is still a chance of mixing of those active ingredients of the first layer and second layer.
There is a chance, yeah. And if that's a big problem, then the best thing to do is do a pellet, and then you can really separate the two layers within a pellet. It's a lot easier to do it using pelleting than it is film coating.
Okay, thank you.
Simon?
Yes.
I think Fabio has a question on the message. You see it?
I don't see any messages. Hold on.
He says, I'm okay. Oh, sorry. Is sticks colored already, or stick range is all neutral color?
Some of the sticks range is only in neutral, but some of the sticks range can be colored. So sticks 2 is neutral, biofriendly is neutral, sticks 1 can be produced in colored form.
And stick 3?
And sticks 3 we're still working on, but there's no reason why that couldn't be colored as well.
I have a question concerning damages to the seed. Do we have an idea of what percentage of seed can be damaged by the physical, mechanical process, or by the imbibition? Or is it no damage at all?
So the seed coating process, we use rotary coaters here, and we often do germination tests between raw and coated, and we're not seeing any damage whatsoever with the rotary coating process. It may be that with some of the older sort of auger type systems that they're a little bit more aggressive, but we don't have those systems, so I'm not too sure. So mechanically, really, seed's quite tough when it's being through that coating process. It's not really doing any damage at all. In terms of imbibition damage, it'll really depend on the seed type and the conditions of planting. So if you look at something like shrunken corn, and you go into a cold, wet field, you could be getting quite a lot of damage through that, and that can be reduced by putting a polymer around the seed that just slows down the water uptake into that seed.
Okay. So if you handle it right, there should be no damage.
Yeah.
Okay.
So what about, as an extension of that question, Simon, larger coaters, very big coaters with a very powerful action as a rotary coater?
You are getting a lot of higher forces in bigger machines. We don't have one to test, unfortunately. What you'll find that really happens in the larger machine is that the forces are so great that you'll put a nice coating onto the seed, but it'll rub off again in the machine because it's too large for the job. As to actual germination damage, I'm not sure.
So they're really geared towards tougher seed types or more sturdy coatings?
Yeah, I think with the larger machines, you have to ensure that you have a full load in the machine. I don't think they're suitable for part loads, and that way the actual energy that gets passed on to individual seeds is less.
Thank you.
Hi Simon, this is Shakil.
Hello?
Yeah, Simon, Shakil here. My question is, can we use growth promoter as a binder?
Depends which growth promoter you're looking at, I think. Did you have one in mind?
No, is there a possibility, is there any chemical that could be used as a binder and a growth promoter, or it is mixed in the polymer?
So if you were looking at growth promotion, then what you would do is you would just take one of your normal polymers and add the material to that polymer and apply them together.
Uh-huh.
Yeah, and we're going to start doing some of that work hopefully at the end of this year. So I'll let you know how we get on.
Okay, thank you.
What seed type do you have in mind, Shaquille?
Sorry?
Do you have a particular seed type in mind that you're...
No, it's a just general question.
Yeah. No, we'd all love to see something like that. So it's, yeah, terrific.
All right, thank you.
So Simon, if I can ask, just with regards to other ingredients in the polymer, in China, we're seeing all the ingredients in one, the color, the polymer, the active ingredient, even in the container for sale. Is there anyone else, I suppose, just to throw it open to the group, does anyone else see that in different parts of the world where the active is actually sold already added in the container as one product?
Uh-huh.
Hello? No, I'll take that as a no. It seems to be a Chinese thing that it is available all in one, but maybe no one else is seeing that. So it's it definitely can't be sold that way here in Australia because we'd have to look at registration. Any other questions? Once again, any other questions? We're right on the half hour here, so if that's the case, and we're recording the session today, Simon. I'm not with Simon. We're in different locations.
Might have missed a bit at the beginning, but most of it we've got.
All right. And did anyone have a look on the portal to see, or have any trouble getting on the portal to review last week's recorded session?
Yes, I tried to do it, but I couldn't get it. I mean, I couldn't get into the link.
Okay. Could you, Jonathan, maybe ask that question through to Christine? You got Christine's email address, and just ask her, and she'll be able to help you through it. She's the expert on the portal, and she sets up everything up there. So maybe just ask if you've had concerns, and she'll be able to help you out.
Okay.
Very good. All right. Well, we're probably just about done. And once again, Simon, excellent. Thank you very much. And yeah, look, I really enjoyed last week's as this week's, and it's great information and really good presentation of why you've done the graphics, and it's very visual. So yeah, thanks, Simon. Thanks, everyone. Any other final questions?
Thanks, Simon. Good work.
Thanks, Simon.
Yeah, thank you, Simon.
If you can just hang on there, Fabio. We'll say goodbye to everyone else then. Thank you.
Bye.
Goodbye.